Welcome to TaleLearCode. Here there will be tales about software development, learning from each other, code to build solutions. And now your host, Chad Green.
All right, so we should be broadcasting. It says we're live. All right, welcome everyone. Thank everyone here. Anyone who's on stream, of course, we just went live, so people won't join for a couple minutes, but that's fine. Number one, happy holidays to everyone. I hope everyone's been having a great holiday so far. I hope you all had a good Thanksgiving. Same. Couple slides. I mean, you all are old hats to all this, but obviously want to thank our sponsors, Modus, for providing the space. It's actually, like I said, this turned out to be nicer than I was expecting to be. And this will where we will be for a while, right? With numbers being now, it makes more sense to be up here anyways. Plus, like I say, I have a hard wire, so I know the internet will work, which is a good thing. So, and then Tech for bringing the food. Thank you so much. Really do appreciate that. You all know this, but Codepalooza, August 19th through 17th through 19th. I will say this: the Cyber Week sale is actually still there because I have to manually change the prices, and I haven't gone and manually changed the prices. So if you haven't bought tickets yet, I'm going to keep them on. I'm going to keep them at that price until the first of the year, because why not?
Thank you for that price.
Yes. Well, it's not the price you got it for, even better price.
What's that?
You got it if you already bought it already. You actually got it for a better price, but it's still the 40% off.
I think that's the other half price.
Yep.
Mm-hmm. I think that's
So I talked about this a little bit last month, but I haven't done much. But I do plan on getting the other user groups going. My goal is January, but considering that it's December 14th, and I still haven't scheduled yet. Maybe it'll be February. But definitely, so Louisville Azure will get that back going. It was just getting started when the pandemic hit. But then the IT happy hour, the tech ladies want to get that going again, and tech leaders. So more details about that soon. And then, just like normal, I hope you all enjoy me at BJ's. All right, so this month I asked Sean Whitesell. Actually, I have seen this presentation before. This is actually a good presentation, which is why I asked him to do it here. And what I liked is it's different, right? Because we always talk about, when we talk about the cloud here, we always talk about Azure. So here we'll get some knowledge in AWS, which I know me personally I'm trying to learn more about. Because we at Glennis we are using both. We're not multi-cloud, but we are using both AWS and Azure. We just don't have, none of our products are in both. But so I'm definitely trying to learn more. So this is a really good thing. So tonight, this is Sean Whitesell. Actually, he has spoken here before. He's also spoken at Codepalooza. Too many codes and Louisvilles and such. As you can see, he is a cloud architect and president at the Tulsa.net. And sure enough, he was foolish enough to write a book. Can you tell that Sean and I are good friends? I'm going to rib him the whole night. But I mean, I thought I added him to the stream. His book. Actually, I saw, Sean, that now they're saying like January 15th is the release date.
It would not surprise me. There's a small editing issue going on right now.
So I mean, when I was pulling the picture for this from Amazon, that's what I think that's what I know. It's definitely said January. I think it said the 15th. So, I have not read the book, obviously, because it hasn't come out, but I have definitely seen parts of it, and I'm looking forward to seeing the whole book. So with that, now I've really set you up for everything. I'm going to turn it over to you.
All right. Let me reshare my screen.
Reshare.
Yeah, I hit a wrong button earlier. So
not a problem. So there, you are now added to that. I'm going to remove us from the screen.
All right. All right. So it sounds like everybody went away. So I guess everything's good on my end. Awesome. I see Joe. Thanks for visiting on Twitch on TaleLearCode. I'm going to attempt to keep an eye over there with some of the comments and questions over there. We'll see. I'm not sure on that. All right. So what we're going to be discussing today is understanding a little bit more about serverless architecture, and while you're designing it, some things to consider. And this specifically is for the AWS edition of this. And later I'll make one for Azure, but for right now it's the AWS version of this. And as Chad mentioned earlier, that kind of learning a little bit about AWS, it is another beast in itself. I've got a lot more experience with Azure, but jumping into AWS, you can certainly found a lot of good hurdles to jump over. And so this presentation is a little bit about some of those things that I've learned in designing a serverless architecture. So our goals for this presentation is, well, we're going to basically kind of going through as if we're going to create an application, and we're going to use AWS Lambdas. And I'll describe all of these pieces as we go along. And this application is meant to be like a batch processing system for uploading files into the S3 bucket. And then we'll use Lambdas for processing those files as they're uploaded, and to kind of get another idea about how to handle events. Now, and I'll say this too, we're not going to actually process files specifically, but the idea is that you're going to see a file that gets uploaded and then gets moved to a different folder, and as if it's been processed. The actual guts of the processing, that's for you to build in later as you want. Then as we process files, we're going to log some stat information about the files and about the job, and we're going to send that over in Dynamo Db. And then we will use a queue service to kind of train some messaging that's going throughout. And in the end, we want this to email a user when the job is done. There's a little caveat on that right only emails me, and with what's done, is set up for only a single user or email recipient on that. And then time permitting, and we'll look at messing with API access through an API gateway to get access to the data that's stored in that Dynamo DB. So while we're looking at the application, let's look at some of the player cards, if you will, the architectural components, and understand a little bit more about the details of them. When we talk about an AWS Lambda, the first thing to know is that they're serverless. And that doesn't mean that there is no server. There's no server for you to manage. It is beautiful in and of itself. And the reason why is because there's no server to manage, no servers to patch. Everybody's scrambling for this Log4j patch that's going out right now. Well, when you work with Lambdas, there's no servers for you to worry about. Now, there's going to be a con with that, in that the Lambdas are meant for short processes. And we'll show you a little bit more of the details on that a little bit later. And you can create Lambdas using multiple programming languages as Python, Node.js, .NET, etc. And you can trigger a Lambda by a list of things, and I'll show you that list in just a bit as well. So not only can you trigger a Lambda, and it will receive information about the trigger, about the event, etc. But you can also trigger something else from a Lambda, and so you can kind of continue this processing through. And you do get access to environment variables, so you can control each of the instances of a Lambda, and that way, every instance of a specific Lambda will receive the same environment variables. You can also control runtime parameters, such as the amount of memory it's allowed to use, and I'll discuss that in a little bit as well, because how you select that will change how much you're paying for that Lambda time. As well as you can put a max amount of runtime on there. So for example, since I said these are short-lived processing jobs, you may say, well, if this job that I've set this thing to, it should never go beyond, say, 5 seconds. You might set the max at, say, 7 seconds. And that way, if there's ever an issue, maybe it's exception handling, something logging, you get a little time to work. But then if it's a runaway process, it'll have a max, and it'll hit that max and kill it so that you don't end up with extremely large charges. And Lambdas are built on top of a system called Firecracker, and it handles the auto scaling. And the beautiful thing about this is, with that system listening to all the demands coming in and those triggers for the instances of the Lambdas, they have an extremely fast startup time. Depending on the size of your code, you may see a cold start of, say, 300 milliseconds, but you're guaranteed to be around 600 milliseconds or less. And I've seen better than that. I've seen between 200 and 300 milliseconds on a cold start, but that's fine. It's you're going to see how that changes depending on the size of your code. If you do like a Hello World app where you're just going to wake up, log, it probably just take maybe 50 milliseconds. After there's an instance running, and after it does and completes that job, it's going to stay alive with some idle time and then wait for the next trigger. If there is no more triggers coming in, it will die off. You only get charged for the actual time it ran, not for the listening time. So if it sits there and processes a job and then comes back to just sits there waiting for another trigger and it never happens, you're only paying for that one time. So then we're going to look at the Amazon Simple Storage Solution, the S3 bucket. And Amazon has an interesting naming convention. And I had to learn about this when I was learning about EC2s. I'm thinking, well, I know EC2 is about virtual machines. Okay, so when are those deprecating and when is there going to be an EC3? I was quickly pointed out that that's not what that is. So S3 simply means that there's 3 words. So I'll start with S, and EC2 is Elastic Cloud Computing. And there's 2 C's. So EC, then there's just 2 C's. So simple enough, and that was the point of it, is try to be simple enough to memorize. So with an S3 bucket, that is the Amazon storage solution. Now they have varied types of storage depending on what your needs are, such as you can store files and they can trigger things on upload, which we're going to make use of. But you can also set up a type of bucket. It's called a glacier, so that if you know that you have some files that will not be accessed very often at all, and you can afford some time for it to essentially thaw, then you can use a glacier, which is an extremely cheap way of storing. So you might have some backup files that are, let's just say they're 2 weeks old, and then you move them to a glacier. And if you ever need them back, well, then you give it some time and then you can get your files back, and it's extremely cheap. You can also host a static website from an S3 bucket, and there are some documentations on how to do that. Next on the list is the Amazon Dynamo DB. This is a really nice NoSQL type database, and there's kind of a free tier. So if you set up just a very simple table and a very small amount of data, it's can either be free or very, very cheap. And you can also manage some triggers based on that events going on in the Dynamo DB. And because it's a NoSQL type of database, there's no relation between one table to another. Any kind of implied relation is for your application to basically adhere to. The database itself will not keep track of that. As well, you get geo-replication per table. So you can think of it as each table is a storage unit of itself. And you can set it up and have it replicated to any of the other AWS regions. And they do act as multi-write, meaning that if I have over in US East 1, I've got my main table there, and I want to do a geo-replication to, say, US West 2, if I write data and save it over in West 2, it is replicated to East 1. There is no governance, and you don't have to control which one is which as far as the master and the any kind of like a read-only copy doesn't have that. Next up is we have the Amazon SQS. This is that simple queue service. This is for messaging solutions. It provides a queue that will hold on to your messages until there is a consumer, meaning that it provides a little bit of a buffer. So if that consumer is not readily available, it'll store it for a little while, and you can control some of the settings on that. It is also very fast. So with a consumer, as soon as a message is received, and it sends it to a consumer extremely quickly. You also have the option for FIFO, first in, first out. And along with that, if you want, is it adds a little bit of process, therefore a little bit of cost, but you can add the chance for deduplication. So since it's a first in, first out, and you might have a retransmission of a message, therefore kind of a duplicate, it will attempt to weed those out, and so you only get one message and not all the other duplicates. Next up is the Amazon API Gateway. This is that entry point service for AWS for any kind of APIs that you want AWS to provide as a service. You do get REST and HTTP endpoints. There is web sockets as well, but primarily you'll see the REST and the HTTP type of endpoints. The difference being is they handle different requirements. So let's see, the REST is going to provide you a lot more details as far as if you're going to do like a web API type of a solution, whereas the HTTP type of endpoint is if you're going to use it for a web hosting type of access. And with, for example, I have an authorizer on there. You can provide a way of putting in a Lambda as your authorizer. So as a call comes into the API gateway, it will look at the incoming headers and the body, where it's coming from, etc. And you have an opportunity to look at some details and to provide that logic to govern whether or not it's going to be allowed to go to the rest of the API gateway that you have set up, or go ahead and deny it, in which case the API gateway will return some HTTP error code that you tell it to. What's really interesting is if you do the HTTP endpoint type, you can use a JOT-based authorizer. So you can set this up with something like Auth0 or Okta as being the JOT provider for your sign-on. And then as that call comes into the API gateway, it can look at that JOT and provide some validation against that to prove that that's a worthy call coming in, an approved call. You can also supply some access policies so that you can have it so that you're only from a specific IP address is allowed to make it in, or maybe it's a private API gateway. Maybe you're going to use this internal to your organization. You can set private endpoints. You may even restrict it to only a specific AWS account. Maybe you have an accounting type of situation and you've got multiple AWS accounts, and only this other account is allowed to call the API gateway in this other AWS account. So you can set up all kinds of access restrictions on there. As well, you can do CORS handling which is absolutely a pain in the tail. But with the HTTP type endpoint, you can use CORS setup, and you get to manage what kinds of the allow origin, the allow methods, and such that you want to set up. Both of them, you can set up API keys and usage plans, and even set this up so if you are creating a SaaS type of product, a software as a service product, and you want to sell this on the AWS marketplace, when you do and get listed, you'll be given a marketplace code. And you, in the usage plans that you set up, you can supply that marketplace code. And maybe you have got a basic usage plan, so they're allowed to only do so many calls per second. Whereas on a different usage plan, they're able to go at a much higher rate, things like that. And you get to have it create the API keys that are allowed in. And you can also set it up so that the API endpoints are required, or you can turn that off as to whether or not the API key is allowed in. And but you can also import an API key, so it doesn't have to be one format. You can come up with your own format of what an API key looks like and import those in. Let's see, what else? Amazon Simple Notification Service. This is like the SQS, where it is meant for messaging, but this is for that pub sub model. There is no queue. So once a message is triggered through SNS, it's going to send that out. And if there are subscribers, great, they're going to receive that. If not, out it goes. And it's really meant for those simple one-off notifications. There's no retry. There's no, you're not going to be able to set up FIFO or any kind of dedupe. Once they're coming in, they're going to be sent out to any receivers if they are already there. And what I'm using it for here too is that you can actually use it for email. The caveat is with this is not an email service. So I can have a SNS topic set up, and when it's triggered, it will send a message to my email address. And I had to go through the process of giving it my email address and then verifying that I'm allowing that to send messages to me. I cannot put in say a form and I just put in somebody's email and out it goes and meant for spamming anybody that I want. It will not work like that. Now, if you need something similar to that, Amazon does have a simple email service, in which case you can set up with your domain and then validate that you own that domain, and you can set up your MX records through your registrar, etc., and then set up some other details like a DKIM for securing those emails. And then going through a process that once you are approved, then you're able to send emails out and use it for marketing purposes. All right, so those are our player cards. These are the different services and products that we're going to be using throughout the building of this application. So as I mentioned, we're going to have a Lambda that's simply triggered, and we're going to look at what's going to trigger this Lambda. But the interesting thing about this Lambda is once it's triggered, there's going to be an instance of that one Lambda created. And then as other triggers occur, then there will be other instances of that Lambda created. So it's going to auto scale. Now it will auto scale up. And then, like I said, if there are some idle time, then it will scale down, even down to 0 instances. And you only get charged for the time that it actually does, the Lambda processes any kind of work. You are not charged for any of the idle time. So we've got a database. For example, you can set up a Lambda connected as a trigger to it from a database. You can use AWS Redshift, for example. You can set that up as a user-defined function. You can do that with SQL Server as well. I'm not 100% sure with RDS, but you can do it on those other two. And when a Lambda is triggered or want to make a call out, you can call through into another API gateway through a system, even a private one using the execute API endpoint. Okay, so we're going to look at creating this architecture, and we understand that we're going to have some files coming into a bucket, an S3 bucket, and the fact that they got uploaded is the trigger of a Lambda that's going to grab information about this file. And this can be used for various reasons, and we'll discuss that as we go through here. And then as that grabs this details about that uploaded file, it's going to create log entries into Dynamo DB. Now, one of the things we're going to decide is, well, how about this first Lambda be kind of that gatekeeper, if you will? It's going to look at the file that's uploaded and decide, is this a file that we really should be processing? Maybe somebody uploaded a picture and that's not what we meant. Maybe we're looking for Excel files or vice versa, whatever. So then as the Lambda says, okay, well, this file that got uploaded is an approved one, we're going to log some entries into Dynamo DB, and then we're going to have that Lambda call a different Lambda. And this second Lambda will go and to the S3 bucket, grab that file, process the contents, and then spit that out to another S3 bucket, another location in S3. Now, here's something interesting. This is where I want to start discussing a lot of the considerations that you should have when you're designing out your serverless architectures. And this is, should you really have a Lambda calling another Lambda? Think of it this way. Let's say that that first Lambda takes, and I'm just going to pick some numbers just so that we have something to gauge by. Let's say it takes 1 second to decide, all right, this is the kind of the file that we need to process. And it calls the other Lambda. Let's say it takes 10 seconds to process the contents of that file. The problem with this is that the second Lambda, you're going to be charged for that processing time of 10 seconds. But the Lambda that called it by doing a direct call and hanging around for the answer or for that job to be done is not done at 1 second. It's done now at 11, maybe even 12 seconds, depending on what it was going to do after the second Lambda was completed. So now the second Lambda that processes the work, you're going to be charged 10 seconds, where the first Lambda is now charging you at 11 seconds. Well, there's really no need for that. Now you're wasting money. Now, I realize that time with the Lambda, granted, it's billed in milliseconds as well. So if something runs exactly 50.2 milliseconds, they always round up and you're charged the 51 milliseconds. So this is where we need to understand some of the other considerations regarding what we should be doing here. Well, I don't want to pay extra. So is there a better way for the Lambda to trigger the other Lambda and tell it that this is a file that you do need to process? Well, this is where we come in with something like an SQS. We set up a simple queue service. We'll set up a message queue. It's going to receive that message, and then it will trigger the other Lambda. And then as it goes through, it can process the message. It says, all right, this is the file I need to go and grab. So it's going to go to the S3 bucket, grab that file, look at the contents of it, process that, put the output into another file location, And let's say that it needs to notify somebody that the job is done. Now it can send a message through SNS that's been set up to email somebody out. So is this going to work for us? Well, the quick answer is yes, because now the first Lambda is only charged for that processing time. And let's say that it's 1 second, but now it's done at the 1 second mark. It decided that this is the file we do want to process, and it sent off a message. Now, it did not directly call the other Lambda, and yes, I need to delete that arrow. But instead of it making that direct call, sends that message, the second Lambda is triggered, it picks that up, it does its 10 seconds of processing, and now instead of having a total charge of 21 seconds for that one file, now it's only 11 seconds. Again, when you're looking at small bits of Lambda and they're only going to run at a very short time, they are cheap. They are extremely cheap. In fact, your first 1 million calls in a month are free. But there's a little caveats to that. So this is where we still want to decide, well, how often we're going to be processing files. Well, is the trigger the right thing to do? Is this the right setup? Now, this makes a lot of assumptions in that we're not going to process large files. Because really, if we're going to process large files, there are other services meant for that. And you might even use a VM or an EC2 instance to set that up. You may even go so far as to set up an EKS system using Fargate so that you're still serverless, but your processing power is meant to hang around a lot more than a Lambda instance. So we're already making decisions right here by using Lambdas that it's still serverless, but they're also meant for short-lived processing. So be very careful of that when you decide to build out a file processing system. Another consideration that you need to have here is, what does the message body look like? What information are you grabbing from the file in S3? Then you're going to create a message to send it to SQS that the other Lambda must pick up. So what does that message look like? So then the second Lambda, as it's developed, needs to also be able to consume that message and understand the body of that message by what do you mean by where's the file location, etc. Also, that Lambda must have read capabilities to one location and at least write capabilities to another location. So now you've got some security involved with the ability to read and write files from those different S3 bucket locations. As well, it needs to also have the rights to receive a message from SQS. Yes, even setting up access policies there is a thing. There is access control over everything in AWS. Everything is a deny by default. So you'll have to understand a little bit of what's called IAM, the identity and access management, as well as how they apply at different services. For example, if Chad is going to be the one that uploads a file to that S3 bucket location, I can narrow that down so that only Chad can upload a file. And I would do that through going through the IAM service in AWS and as well as the S3 service. But with SQS service, you do all that access policy management inside that SQS service itself, not in IAM. I don't know why they set it up that way, but that's one of those little gotchas that you've got to understand where you actually administer those policies. So then we're going to break this out or expand this out even further. And now we're going to have a user that wants to access the API gateway. So we have to have an endpoint. We have to have a setup, what's the body of that call going to look like? Does it have permissions to do it? And then it's going to call the backend Lambda. So we don't have to have an EC2 instance. The API gateway endpoint that we're going to call can be directly tied to a different Lambda. And then that Lambda can have read access over to the Dynamo DB table so that it can call and receive information out of the various tables. So let's go over a few of these things. How are the files getting into and out of the S3 bucket? So it doesn't have to be public. In fact, S3 buckets are private by default. You have to go through extra steps and select extra boxes if you really want that bucket to be public. So then if they're private, then who can get access to them? If you're doing a multi-departmental type of solution with multiple AWS accounts, you're going to have to set it up so that either certain people or certain roles are allowed access to those S3 buckets. And what's that maximum file size and execution time? This is one of those things where you might have to kind of play with this a little bit. If you're processing some text files, and let's just say that they're 1 kilobyte or 2 kilobyte max, you're fine. But what if you're processing images, really large images? You might run into some of the processing power restrictions, meaning that you may run out of memory or time in a Lambda and may need to find a different solution. So definitely make proof of concept type solutions for understanding your needs. And again, what is that file type? Is it going to process an image and create a thumbnail out of it, or is it going to work on Excel files and gather some information out of that? You're going to have to understand what kind of file types you're going to be dealing with. How are those Lambdas meant to communicate with each other? Are you going to do asynchronous with RPC? That's that one Lambda calling another Lambda directly. Or are you going to do an asynchronous call with messaging? Which brings up another point I forgot to mention earlier. By having a SQS, a message queue in between, then this also allows as like a buffer. Meaning that what if the first Lambda is able to work, it's up running, and it's trying to say that, yes, this is a file that needs to be processed, but the second Lambda still has some startup costs, some cold start time. And what if that is, let's just say 300 milliseconds? Well, the first Lambda could be done after, say, 2 milliseconds, and then the other one is still waiting on a cold start at 300 milliseconds. By having a SQS queue, you allow some of that buffering of time. So then when the other Lambda is triggered by that message, then it's able to pick that up on its own time and work with it from there. So you're giving yourself a little bit of time buffering there. And then we say, well, how do we know when we're done with the job? In this case, we can do an email from an SNS topic. So what else should we be looking at? Well, how are we going to govern access to the data store? Should we have it read only or read and write? Well, who has access to that? Since we're talking about logging details and some stats from the different jobs running, the Lambdas, then they need write access into Dynamo DB. And the way they have that with their writes is you either have read only or you have both read and write. Essentially, you have full access at that point. Well, then we have this third Lambda that's going to be reached by a user in the through the API gateway, and we want that role that it's going to be executing to have only read-only access. That way, they can able to get some data out, but they cannot affect that data that's stored. Does that data need to be geo-replicated? Should it be replicated to other regions? What about other AWS accounts, which is another discussion in and of itself. And what is the format of that data being stored? It kind of goes back with that messaging. What does the body of that message look like? You're going to need to understand what data should be stored and how's that going to work for you. And since Dynamo DB is a NoSQL database, from one record to another, there is no schema, so the body is allowed to change one record to another. So if you have, let's say you've got 10,000 records in there, and you've processed several thousands of files, and then you decide, well, we're going to make a version 2 of this, we need to change. Well, simply change the body of that data being stored, and you don't have to work with anything of the previous data. Let's see, what about accessing the API gateway? So should you be using an authorizer? Should you be using API keys? What kind of users are you going to allow? Should this be a public endpoint or a private endpoint? Well, if it's private, how are they going to get access to it? And should we restrict that by other means? What's the payload format? Do we want this available by curl and postman and something else? Or are you going to do more of a binary type of setup there? And do any of these services need to be on a VPC? Now, that's something I haven't discussed yet. Let's see if I can touch on that for just a second. AWS has what's called a VPC. In fact, when you create your first account, every account has a default VPC. VPC stands for Virtual Private Cloud. And what that really is a category of services that are available to you, meaning that you have a default VPC, therefore you have a default virtual network. You have subnets. And in fact, if you're going to pick an account over in US East 1, then you're going to have 6 availability zones. You start out with 6 different subnets, 1 in each of the availability zones. And I believe the number is 4,019 IP addresses in each one of them. It's over 4,000. I don't remember the exact number, but over 4,000 IP addresses in each of the subnets. And you also you get access to security groups, routing tables. And so for VPCs, this is for where you're going to control your network access to things. Your endpoint services, etc. So like I said, every AWS account has a default one. You can delete it. You can go and create new ones. All of the subnets that are provided by default are public. If you need a private subnet, you create a new route table, leave off a route for the internet, and then change your subnet association. So you go through each of your subnets and say, instead of going to this route table, go to this other one that doesn't provide access to the internet. Now you have a private subnet. Some services that you may work with require private subnets. So that's the easiest way to make them private. All right. So one of the things that I forgot to do is set up Visual Studio. So let me get that open. And I've already updated to 2022. So hopefully I can find my stuff, or I will default to 2019. Let me open that right quick. So while we're at a quick stopping point, Chad, is there any questions and any questions from you that I should jump on? And Chad, if you're speaking, I don't hear you. Loading up Visual Studio so that I can advance to the next section of this.
So no, I was saying that there have not been any, there's no questions from here, and there haven't been any questions on Twitch.
See, I'm just that amazing. I explain the world and there are no questions.
Exactly.
So looks like Robert Wilson finally got a Twitch account and to jump on over here. Hello, Robert. All right. Okay. Let me switch around a little bit. Let's get back over to here. Okay. That advanced further than I was meant to. Let's go here. And what I want to do now is let's go jump around a little bit and understand some of the details that we're looking at with Lambdas and starting there. And then I'm going to also look at my S3 bucket. And let's see what else I've might have forgotten to get up ahead of time. We'll look at the API gateway and Dynamo DB. And my system is crawling, so this is going to be just a little bit of time to open up a few things. Okay. So one of the things that I've got here is this authorizer Lambda. I'm going to skip that for just a moment. And I've got this S3 file upload Lambda. And so basically I'm in the Lambda section, and we have Lambdas are listed by functions. And you can tell by what differences about the Lambdas themselves other than the name is you've got runtime differences. And I believe at the moment you cannot do a .NET 6 Lambda. I don't think that's out just yet. It may be coming really soon, though, since they did just get it released. Okay, so I have this S3 file upload Lambda. And let's understand a little bit of the details about this. Again, my system's crawling, so some of these things might take a second. And you notice that I have a trigger by the S3 bucket here, and I'll show you some more differences here. And it's the S3 file upload Lambda. I don't have a destination. It itself is not going to do a trigger based on this. It is .NET Core 3.1. And I have what's called a handler. And this is me telling the Lambda system, that Firecracker system, that this is it's running .NET Core 3.1, and that I have an assembly code called upload trigger Lambda that has a namespace, upload trigger Lambda, a wonderful class name called function, and a wonderful entry point method called function handler. Yes, I went with some defaults just to point them out. So we have assembly, namespace, class, and function, method name. So this is using this information to know exactly the entry point of that code when it calls it. And if we look at configuration, this thing is set to a max of 512 megabytes with a max runtime of 15 seconds. Now I can modify this and have a max up to 10 gigs, 240 megs, as well as a max of 15 minutes. Maximum timeout right there is 15 minutes there. So let's leave that. And then I can change the execution role that I've set up, and I just going through the process of creating this, I let it create a default name for the service role, and this has the permissions to execute this Lambda. All right, and we look at triggers. It says this is our bucket of file nuggets, is the name of the S3 bucket. Also, this name is unique across the world globally because it is used as part of an external addressing. So when you do create your S3 bucket, you will have to be globally unique, and it does help you tell you when you are not, and then you have to just go back. The event type is object created, meaning that the object, which is essentially a file, has been created inside this bucket. It will fire this event and is the trigger for this Lambda. And you can set up and add other triggers. There are many other trigger types, such as API Gate. You can either do skills kit. You can work it in your Apache Kafka. If you want to do some streaming, event streaming. Application load balancer. This is really neat. This is a layer 7 load balancer as opposed to the network load balancer, which is layer 4. And so any of these items here can trigger Lambdas. In fact, you can do an event bridge even tied with CloudTrail. So in fact, I just did that on a different account. I have it set up so that if somebody logs in as the root account, the CloudTrail will capture that event and send this information to Event Bridge, and the Event Bridge can trigger something else, such as a Lambda. Apologize on that. I didn't realize the screen was small. Let's see. Dynamo DB can be a trigger. Kinesis, more event streaming, information streaming. Anyway, so we have a lot of options here, including some of the third-party things. If you do a lot with Auth0 or some Atlassian, for example, Datadog for monitoring. This is really neat. Even if you've got, like say, New Relic, if you're watching an EC2 instance, and let's say that it's you find some metric that is above a threshold, you can have it trigger a Lambda as well. PagerDuty, thankfully I'm not on call, and even Shopify. So there's some fantastic third-party items that can help trigger a Lambda. All right, let's do this and see what else good stuff we need to look at. Environment variables, I don't have any set up right now, but they are simply key value pair, and the just .NET Code, the .NET Core does not differ in the way of retrieving an environment. So use the exact same methods there. This simply becomes available in that virtual environment for it. And it is not a Docker container, by the way. If I needed to work with something that is on a network, for example, if you do have a Lambda that is a user tied together as a user-defined function to either Redshift or like SQL Server, those are on a VPC, meaning that they do have an address. So you will need to have this Lambda also be on the network, and you'll have to pick, you can pick all of the subnets, one or more. And what it does is behind the scenes, it will create what's called an ENI, an elastic network interface, to contact over the network this Lambda. And then you can use a security group for controlling some of the network rules there. And notice here that I've got some different rules. Okay. Let's see if there's anything else that I need to worry about. If you want to do something like, I need to have never has a cold start, then you can see configuration, and they are $111 a piece per month. I would have had to create AS in a version. I don't think I've got any available at the moment, but they will be $111 per month. And let's see, what else good stuff should I be showing you? If I want to create a brand new function, I can go to my choices of runtime. This is those programming languages. You can do Ruby 2.7, Python 3.9, etc. You can do Java, you can do Go, .NET Core 3.1. There are other supported options as well if you want to go to a previous version of Python, for example. And with Node.js being at 14, you can do a 12.x as well. And if you did something kind of your own bootstrap, then you can also choose one of those. I have never done that though. All right, let's see. We'll make our code for the Lambda. In fact, I'm going to jump over just slightly. So I'm going to go to this file processor Lambda. It's the exact same thing, although it's a different Lambda, so it's going to be a different code base. So let's say I go to file processor Lambda. I'm going to have there's my assembly, right? My namespace, class, and then my method. When I run code, I can upload a zip file that's essentially from the bin output folder of that code, or I can pick out a zip file that's stored in an S3 location. Now, obviously, I would suggest doing some CI/CD, but I don't have any of that set up for this demo. But you can use things like Code Pipeline or even Azure DevOps using the AWS kit there, and then you provide a service account that has permission to reach over and upload file into this Lambda. Behind the scenes, there is an S3 bucket that's storing that code for this Lambda. All right, so when I want to look at, say that I've created my Lambda and I'm looking at code. So what we're going to see is something it's very simple. And what I mean, we're going to have some Amazon S3. We are looking at some is triggered by an event such as triggered by the S3 file type itself. Here I'm using the Amazon Lambda SQS events type. This SQS event is what is actually triggering this function. So here's my space, my class, obviously well named, and then my entry point method. So what here is the uploaded. The first Lambda has decided, yes, this is one we're going to. That maybe the file size is under. Created a message and then sent that message to the SQS, which triggered this Lambda. Received a message. Every Lambda gave a context of type Lambda context, and what the context is to do is to log information about things going on from inside with our code, but we also who and let's see if I did context dot. If I can show real quick, here's my AWS requester, the client context, and about function name and version, probably of the caller, the invoked function ARN. The ARN is the AWS source name, a user, a role, a C, or service, etc. And we can create different, not only log entries, but we can even create different log streams if we needed to. And you even get a glimpse as to how much remaining time do you have in the processing. So if you wanted to loop through some of the details until time is just about to run out, do some cleanup, and then exit, and maybe even store a spot where another end can pick up where you left off. All right, so in this case, I've got my message verifying it's not null, that it's not falsely triggered, which in fact, what we could do, I'll show you this little test. This is the file processor Lambda, and I can pick out a template such as I'm going to say that this was triggered by an SQS message. I can come in here and let's see, not that one, the body, and provide some information for that to be called. And just go up here and hit test. And no, I don't have anything ready to kick that off right at the moment. Okay, so when that happens, then as I get the message and verify it's not null, there are records, and that there in fact is a body. You notice that the records is a collection, and that I need to have at least one here. So I'm going to deserialize the body into an S3 file type. Now, this is a custom file type that I created right here. The file name, the bucket name, and the size. And you can do JSON property name on this. Not that I had to in this particular case, but I wanted to just for demonstration that I can. So as I deserialize that data, and you'll notice right at the top, there's an assembly tag for Lambda Serializer, and it's using the system text JSON that came in the Amazon Lambda library. So you can control this. You can create your own if you really need to. Don't. You're better off just finding the right entry type that you want to work with. All right, so then we deserialize this information from the bot. We're going to not just log this to the CloudWatch, but now we're going to grab so we're going to start with grabbing an Amazon S3 client. We're going to go and grab the object. Notice a file is called an object. And we're going to grab that by that bucket name and the file name. And just like it is with Azure Blob Storage, in S3, there are no folders. So really the slashes that you would think are a folder path are actually part of the file name itself. So we're going to go and grab that object. Now we have a source file. We're going to create some stats about this information. And then we're going to log that details over to Dynamo Db. And then we're going to copy that file object to a destination location. So what I've done here is instead of it being in the upload folder, it's now going to go to the done folder. And because there's technically no folder names, you do this using the paths of the names and a slash. And then when you are looking at the S3 buckets, the folders are more of a virtual way of handling that separation. Then we'll log some more information that it got copied and we received an HTTP status code. Now, which is interesting because when we're doing this copy object, it is actually using an API call to AWS to do this. So you do get an HTTP status code that is a standard HTTP response code to help govern how things worked. If you got a 401, you didn't have access, 403 forbidden, right? Or you're going to get like a 200 that it did succeed. And then, so now that I've copied and I've got that file, and now it's in two different locations. It's still in the upload folder and the done folder. Now I'm going to go and delete the one from the upload folder. And then I say, let's just go notify somebody. So what we're going to do is when I log the entry to Dynamo DB, I've got a Dynamo DB client. I'd create a context on that, and I just say save. Now, something ought to be really interesting on this is there's no username or password or location. So where's it storing it and how? So the way it's doing this, because I did not specify a credentials on here, which I could have, it's running on the context of the Lambdas executing role. And so that executing role has been given permission to go to DynamoDB and write information in, as well as it's running in the exact same region as the Lambda. So it's going to go to the DynamoDB instance in that same region. Then we'll save that off. And when I want to notify someone, I have a simple notification service, the SNS, create a client, and I'm going to publish this message. And remember, I said this is kind of a pub sub model with SNS. So it's a publish subscribe model. It's going to publish and forget about it. Those who have already subscribed will get a message, but there is no queue, so there's no way of kind of redoing anything. All right, let's see. When I have a file stats type, I am able to control, for example, if I did not have this attribute here, it would by default look for a table called file stats. But because I do have an attribute, I'm controlling specifically the name of the database type, table in Dynamo Db that it's to use. So in this case, file process stats. I have a hash key, which is the primary key. Well, I take that back. It is the partition key of the records in this table, the file process stats table. If you have a sort key, the combination of the partition key and the sort key become a primary key. And then I've got some additional details, such as I have a Dynamo DB property of operation, what was it that occurred, as well as the file details about that uploaded and processed file. All right, so let me jump around a little bit more, and I'm going to see if I can find another one of the Lambdas that I want to show you right quick. Chad, if you would, one or any other questions, and how much time do I have?
You have time that you need. Questions. Although I will say we're on the second laptop now, because you did go through one laptop's battery.
Oh my gosh.
So we had to do a hot swap real quick. I'm glad we went to StreamYard, because you kept on going. You didn't even know we left for about 30 seconds.
Oh, wow. Well, you missed a good 30 seconds because it was just solid packed information. Yeah. Okay. So this is the Lambda code for the first one. I really should have done this one first, and I do apologize. So if I look at, go back to, let's go back a little bit. Let's go here. Okay. So we looked at the code for this Lambda, that it's triggered by this SQS message here. And it says, I'm going to go and grab a file, and then I'm going to go place it into another bucket location. And there was some pretend processing. It really didn't do anything, but this is the area where you would, if you're going to actually, say, create a thumbnail or something like that. Right now, I'm going to look at the code inside this Lambda that receives this trigger. You've already seen how it logs stats entries into here. It's the same code as to here. All right, so let me switch over back to that. This is my upload trigger Lambda. And I've got this Lambda serializer on the assembly tag here. And I have an Amazon S3 client. Now notice something really interesting here. And if so this constructor, it's still able to be called by the trigger. But I do have a constructor where I'm supplying an S3 client. But this one is not called by the trigger because it has to be parameterless. So why would I do this? Because if I wanted to do any unit testing, I can inject my own S3 client. Maybe I mock something up, but it allows me to control that in the constructor. This is my point. Even though this is the entry point location for this Lambda, I can still control things when they instantiate, including this very class, when I want to use things like unit testing and integration testing, etc. Now, this entry point receives an S3 event. Unlike the SQS event, this is an S3 event. So it is from the Amazon Lambda S3 events library. And so when you do look at your let's go to look at your NuGet packages, you only have to load what you need. So I know this one specifically is going to be triggered by S3. I don't have any of the code for API gateway, for example. It's not handling anything to do with authorization of the API gateway calls, so or NSNS type triggers or anything like that. So I only loaded what I needed, and that's it. All right, so if I come in here, I've got this S3 event. I'm verifying that there actually is an event by looking at some of the information here. Why do I do this? Because I like doing protective coding, right? As maybe I'm triggering this by the test tab in the function itself through the console, or I can trigger it through the AWS API. But I maybe forgot to, put something in place. And well, if I by doing this is a little defensive coding. That was the word I was looking for. Doing some coding. All right. So notice that says if this object key starts with upload, because here's the thing. When I first made this, it kept going and kept going and kept going. And what happened was when it was copying the file from the upload folder to the done folder, and I was telling you that there are no real such things as folders, they're simply paths, that what was happening is every time I copied it over into that new location, it was triggering this again. So I kept having this circular trigger going. So here I'm saying, look, only trigger or only continue if this if the event object itself, which is the key is that file name, actually starts with upload/. Now I know it's a file that I want to deal with in this upload folder, this virtual upload folder. And also looking to verify that there's actually a size to the object. It's not just an empty object. No sense processing or being triggered on something that's empty. Now, you could also look at this and say, well, I want to make sure this file size is below, 100K, for example. You can bring in some of this right there. And I've got my class that I've made earlier, that file stats, where I'm going to go and log some information over to Dynamo DB. And let's see. Now, this is calling the Lambda directly. So this is how this is being done. Not that so if you remember what I was saying earlier, I do recommend you do not do that. So one, it adds cost, but it also adds execution time. And it's more of a pain because now this caller has to sit and wait for something else. You're better off doing the messaging. If you do want to call a Lambda directly, and maybe this is from code running in EC2 instance. Maybe you've got some .NET code running in a virtual machine and you want it to call and invoke a Lambda. You can do that too. You can have this Amazon Lambda library, and you're going to create what's called an invoke request. I am expecting a request response, meaning I'm going to hang around for it. Yes, I could do this as an event type. Hopefully, show me as an event type is another option that you do have. So then I've got the function name that I want it to go and trigger. Yes, it must be in the same region and in the same account. There might be some hackish ways to get around to another one, maybe through permissions in the client. But in this case, it's expecting this Lambda to be in the exact same region and in the same AWS account. And then I create a payload, which is serializing so I'm going to create a new instance of this S3 file object, and then I serialize it. So now this string is the JSON payload that goes in that request. And then I just simply invoke. Now, like I said, don't do that. I did this really to show you that you can. Instead, you're going to use an Amazon S3 SQS client, and you're going to do a send message. Notice that this one is not a publish. This one is a send. The difference is that remember, is that with a queue, you're going to send a message that's going to sit on a queue for it to be picked up versus a publish, which is for a pub sub event messaging model. And the same thing here, I've got some S3 file information about what's going on here. I serialize that to the message body. And remember what I said earlier is, well, what does that file, what does that message body look like? Well, this is where you're going to have to design that ahead of time. And how do you expect that to appear and to be sent and processed, etc. All right. And then the same thing here, log the entry to the database. Let's see. Now, with that out of the way, let's go and look at some other fun stuff. Any questions while I'm babbling?
Nope.
Wow, I am that entertaining. I just heard giggles. All right, so I'm going to show you one more Lambda to come into the API gateway endpoint, which calls this Lambda, and it's going to retrieve information from Dynamo DB. It's basically going to execute a call on the behalf of that user. All right, so let's take a look at what this does. This particular type of Lambda is not .NET. In fact, instead, it is Node.js. So what this one does in particular, you have Dynamo DB, you have a document client. So now I've got a Dynamo. Also, you have an AWS, which is, you notice the require is AWS SDK. This is really interesting, and I'm not a Node.js developer by any means. In fact, I pulled this from somebody else's demo code, probably AWS demo code. And all I have to have is require AWS SDK, and then I get access to the Dynamo DB library. I don't have to install anything. I don't have to install NPM or anything. And I'm editing this code right here in the UI for the Lambda. And you'll notice then too is that as I have an event HTTP method, such as a GET, it's going to do a Dynamo DB scan on that table name, and it will await this promise, meaning that it's going to sit around and wait for the results. Now, it will also allow through this code is I can delete a file or delete a record, or I can insert one or update one. And then it returns the status code, the body, and the headers through there. So there is no file to upload. Well, I say that there's a zip file right there, which is the zip file of essentially this information right here. You can go through here and create a new file. You can create a new folder. This does not have to be a single file product or application. You can do a far more elaborate coding here in Node.js, and then you could test it, and you can also deploy it. In fact, you cannot execute this and have it available to you until deploy, and then it will wrap this up and send it to the Lambda itself and make it available. And as well, you get the same things as any others where you have a memory and a time limitations, environment variables, and permissions of who can execute this role, etc. So, all right, when I'm looking at this bucket, and I have the upload folder and the done folder, these little virtual folders here themselves. If I look in the upload, it's going to be empty. If I go over here to done, I'm sure there's going to be a file that I forgot to delete. And in fact, let's go ahead and delete it. Oh gosh, yes. Are you really, really double sure, triple sure that you really want to delete it? Then I'll go and delete that object. What question is available, Chad? What do we got?
So there's a question about the testing of the Lambdas. Do you get charged for those tests?
Yes. Any execution of a Lambda, you are charged. Now, if we want to do something real scary, let's go to AWS Lambda Pricing. and I want to show you how awesome this pricing model is. Okay, so it is really, really, really cheap. Let me see if I can go and wait for this to load. Now, you notice that you have memory allocations that you want to concern yourself with. So let's just say I max out 10 gigs, 240 megs, and I'm in this region. Why does this matter? Because California charges more. And you notice that I have cost per 1 millisecond of execution time. Okay. If it is 5 milliseconds of execution time, then it's simply that times 5. But you're going to go with your allocated memory that you have picked in your configuration of that Lambda. One of my examples, like right here, if I look at the for the Node.js, I put it at 512 just to pick something. It does not have to be this big, but I've got a max timeout of 10 seconds. So at 512, it's a whole lot cheaper, right? So then I'm fractions of a penny per millisecond. Also, let me see if I can. So this is for the duration. If you've got gigabyte seconds, again, it's fractions. And you notice then here it's 20 cents per 1 million requests. I hope that pricing doesn't scare you, because that's cheap. That is really, really cheap. In fact, cheap enough that even seriously, just playing around with it, you end up spending, say, $5 a month. That means you have done some really cool playing around with Lambdas. So don't fret from that. Okay, I know what I'm gonna do. Let's go over here. Let's go back over to the AWS console. And Chad, I'm just gonna keep babbling until you cut me off. Let's go to Dynamo DB. And let's go look at that table. So we have a file process stats table that I've created. And so when we're looking at in Dynamo DB, let me shrink this just a hair. And you'll see my list of tables. And I've got this one table. I do not have a sort key. So my partition key is essentially the primary key. If there was a sort key, the combination becomes a primary key. And if you are, 1 second. Come on, get on it. Okay. All right, Chad, I saw your message. All right. So then I've got this table, and I'm going to look at details. I'm not going to dig into a lot of this. I'm just going to show you some exciting things. I can set up global tables and have this, if it will actually click and go. I don't have any replicas, but this is where I would set this up. You can even change your encryption, your at-rest encryption used. You can use a key management service to create a custom managed key in that. All right, so I can go over here to view items, and I think I've got some from the last, I have some from the last demo that I did, and I use the time as the ID, and it says, hey, I've uploaded a upload trigger Lambda PDB file. You can probably tell what folder I was actually in when I found a file just to play with, and it's 11.2 kilobytes of file there. And then here's the bucket name of which it resides, and I'll zoom in just a hair in case that's a little too hard to see. And the operation was, it was triggered by the file versus the other type of entry that I have. Let's go down here, and I have copying. So the file copy event itself, and now I've got obviously a different file that I was playing with, and now this one is 613 kilobytes there. So And you notice that this is an object, a file details object. This is that file stats object serialized into here. Okay, let's zoom out just a hair. So that's where I'm going there. Now I'm going to tell you that, let me see if I have this. Give me 1 second. I'm going to see if this will pull up. And in the meantime, if you do have any questions while this other item is loading, you're more than welcome to ask. And I'm keeping an eye on chat as well. Yeah, Robert, the $111 or $110 a month does add up. Absolutely, it does. But here's the thing. It's one of those things where it's there if you need it. Is by the time you need it, then the $110 is cheap. Because then you're going to have whatever processing you're doing, you're going to charge a client $110 is going to be a drop by the time you actually need to do that. Okay, now I'm waiting for Postman to load. My laptop is extremely busy at the moment. And let's, in the meantime, jump over to API Gateway. So I have a REST endpoint. It is private. And I probably did that just to close this up so that while this is available, nobody else is hitting it. And while, so with your API endpoints, certainly for the public ones, you can set up a custom domain on that endpoint. So instead of calling it like a really long name that it's going to provide, you can provide a nice custom name, but you will need to work with probably like Route 53, which is AWS's DNS manager. In fact, I think it's the only service they offer that is a 100% uptime. All right, so I've got my Lambda here, and I've got my resources. I've got my any here, which means it's going to react to any call. And I do not, let's see, I do have to have an API key in this request. And I'm using an authorizationator for my authorization. If I go over here to my authorizers, I can see this, and it's expecting the API key in the header. And also the results of the authorization is not cached in this case. All right, so that gives me that access ability to govern that. Once this is executed and comes through, let's say that the API key checks out, then this is that Lambda function that it's going to call. And we looked at that Lambda 123, what a beautiful name, as Lambda 123 here. And this is the one running the Node.js code right here. So this is how I can tell and pass in a request that goes in from API gateway over to a Lambda. No, it does not have to be a Lambda. It could be other things, such as another HTTP endpoint, maybe a private one. I can even send it to another AWS service, or even mock it out, etc. So, and let's see if there's anything else that's worthwhile of mentioning this. You can use client certificates. So if you want to do SSL offloading, you can set that up, and the SSL certificates are free. So that is awesome. And then you can set up a resource policy so that only certain people are allowed to execute this call, this large, at this AWS account on this ID using this beautiful endpoint that's called. All right. So we just did a whirlwind of tons and tons of stuff. For the heck of it, let me go, and I'm going to go to upload, and let me go and upload a file. Let's add a file here. Let's see if I can let's go find something that's not private. Let's do this.
Are you frozen? Somebody said, let's do this. See, that's what you get when you say, let's do this. Just checking this, make sure my internet didn't freeze. Oh, of course, I'm on a work laptop, so I'm making sure careful what I show on the screen. Oh no, okay. Twitch is saying he's frozen. They're also frozen. We say his internet has been a little bit flaky.
I noticed it was.
What I was going to ask is, where's he at? When I was asking.
Oklahoma.
Okay.
All right, let's. So I guess actually it looks like we've lost. Yeah, we have lost him. He's actually off the call here. So we'll give him a moment, see if he can get back on. But definitely an interesting way of seeing things, especially if you've done Azure functions, kind of comparing Azure functions to AWS. I know like I said, I still haven't had a chance to actually doing Lambdas, but I've seen a couple demos and stuff. And there he comes. It's definitely interesting to see how they approach the things differently. Hey, there you are.
Yeah, my VPN cut me off.
Well, that's what you get for having a VPN.
Well, yeah.
You want to try to protect yourself, but it really protected you.
Yeah, exactly. Let me reshare because I'll do this last little piece and then let's see if it's worth doing. So let me upload while you're sharing my screen. I'm going to attempt to, let me go and find just a very quick file here. Oh, there we go. I've got a file for Q, some notes I did on that. So let me upload. It's only 2 kilobytes. So let's see if this actually works and does not kill. Okay, there we go. So it didn't kill my network time. So 1.8 now uploaded it and it's already gone. And now it's over into the done folder. So what that did is it quickly triggered the Lambdas, even while I was thinking, okay, well, let's double check that it actually got uploaded. It's already been processed and sent over, copied over to the done folder here. And so it helps to have a very small file to deal with. So there's that quick proof that all of this little setup actually did work. So other than that, what questions are there?
Pretty cool. I mean, any other questions from here? We'll give the Twitch stream a moment because it always takes a moment for.
Yeah. And then a little bit about me, cloud architect over at TokenX, Microsoft MVP, user group leader of the Tulsa.net user group, and blame it on Log4j. That's what it is. I will be attempting to blog more often starting in January. And yes, I am on Twitch. And I will also attempt to be streaming
you're on
again.
Twitch?
Yes, I know.
I mean,
I
even
know.
I can give you a hard time about being on Twitch.
Yeah, yeah, I know. You actually got back to streaming. I'm still working on it. But now that the book is done, I should be able to do a little bit more, spend a little bit more time doing some Twitch streams. So there you go. Thank you, Chad.
Well, thank you. Thank you so much. I really do appreciate that. All right. Let's end the.
Bye to everybody on Twitch.
All right. So.